Okay, so hello and welcome. Here I am. Here we are, rather. Here I am, here we are. I wanted to return to what we were doing previously, solving various LeetCode problems. So we'll get into that. We will get into that. Suddenly got very sleepy and tired. But yeah, I think we'll just keep going. So here we have another one. We got downvoted quite a bit, so it's probably going to be kind of long, kind of challenging. I'm going to try to go quickly through these problems. Let's see how long it takes us. Or somewhat quickly, not crazy, but... Alright, so solve a given equation, return the value of x in the form of a string. X equals value. The equation contains only plus minus operation, the variable x and its coefficient. So return no solution if there is no solution for the equation, or infinite solutions if there are infinite solutions for the equation. If there's exactly one solution for the equation, we ensure that the value of x is an integer. The equation x plus 5 minus 3 plus x equals 6 plus x minus 2 equals output x equals 2. Alright, x equals x, infinite solutions, equation 2x equals x equals 0. Equation 2x plus 3x minus 6x equals x plus 2, x equals negative 1. Equation x equals x plus 2, no solution. Okay. Equation length is between 3 and 1,000 characters. Equation is only one equal sign. Equation consists of integers with an absolute value in the range 0 to 100, without any leading zeros, and the variable x. Okay. Yeah, I can see this is a bit of a pain in the neck to code. Okay. So there aren't, it's just strictly linear equations though in one variable, so this shouldn't be too bad. Basically, what you're going to do is collect all of the x values on the left side, all the x values on the right side, collect all the x coefficient, x coefficients on the left side, or really get the coefficient of x on the left and the integer on the left as well. You're going to parse out each number more or less. So there's some parsing code we need to write in order to parse out each piece. But I think the algorithm, once we've got the parsing done, so we'll have like sort of a, so we'll have, I guess we'll have a parsing routine. We'll split this on the equal sign into two strings and parse each of those, the left string and the right string, and we'll have a tuple that'll give us the x coefficients and the, I guess, sort of x raised to the first coefficients and x raised to the 0 coefficients, something like that. And then we have on the left, we have on the right, we have these two values. We can actually combine them by subtracting the right side from the left side, and for both values, and so we can sort of zero out our equations. And then what we would say is we would set x is going to be equal to the integer, the x raised to 0 coefficients, right, the second coefficients, divided by the first coefficients. And after we've sort of zero things out. Now, if x is, basically if the x coefficient is 0, then there are no solutions. No, excuse me. There are infinite solutions if the x coefficients are 0 and the right side values are 0. In other words, this gives you 0 equals 0. In other words, if it's always true for all x's, our equation, then we have infinite solutions. That occurs exactly when not only is x 0, the x coefficients are 0, but also the right hand side is equal to 0 as well, which means that, you know, we subtract away everything, we get 0 and 0 for our tuple. That's infinite solutions. It's no solution if x is 0 and in other words, x is 0 coefficients, and then the right side is actually not 0 as well. that means there's no solution. So it's actually pretty simple. It's pretty relatively straightforward, I think. We just need to write the parsing routines, and that's the logic for the sort of the algorithm. So it's not too bad. But there's a tricky thing here where we're parsing each integer, and I guess, okay, the integers are non-zero. Okay, that's important, because that means that the plus and minus, we can sort of take that to be, like, is there such a thing as adding a negative number or subtracting a negative number, things like that? Like, you can sort of add, like, yeah, you kind of make things more complicated if you wanted to, but if we make sure that the numbers themselves are actually, all the coefficients are positive, and then the operations themselves will define sort of what we're dealing with, and it's a little bit easier to parse, I think. Now the question is, do I want to write my own custom parsing routine, or do I want to try to parse this in a different way? And I actually don't know what I want to do here. Certainly one step is going to be breaking on the equal sign, the left and right parts. We can substring two substrings, the left and right parts on the equal sign. I guess that's not so bad. And then the parsing routine, right, we'll return a tuple of integers that represent the coefficients, or really it would be a pair, but a tuple's fine too. It would be the coefficients of the x values, the coefficients of the, I guess it'd be plain integers. I'm not sure how to express that cleanly. The other integers that aren't paired up with, that are the other, I don't know how to express this, like the integers that aren't coefficients, we'll say that, yeah. So sum all those together. Now the tricky thing is, how do we parse out each of these pieces? Like, I kind of want to parse on each operation maybe. And then, so you have elements, I guess. You could parse on operations, and then you have each of the elements. But the part that's challenging is, like, basically we want to simplify these expressions, right? That's kind of what we're getting at. But what I want to say is, if there's an x value in your element that you just parsed out, then you remove that value from consideration, and then you could take the rest of the string. You can parse out an integer. I think we have s to I. Yeah, s to I we can use. Also I think these go from 0 to 100? Yeah, I do. Okay, interesting. So I think what we're going to do is the operation itself will include in the string, because when you can parse that, you get -2, right, if you included that. So yeah, we can parse this into parse out each of the expression into components or pieces, elements, and we'll include the operation, and we'll take sort of, I guess we'll take the pieces including, so inclusive left to right, left side inclusive, right side exclusive of the characters, and the left side inclusive is, we're going to split on the, or we're going to break it up on the operations themselves, and we'll include those in the string. So here we'll get x plus 5, x is one element, plus 5 is another element, -3 is another element, plus x is another element. And then we're going to do, for the things that have an x in them, we're going to remove the x. But we also have to be very careful, because very subtle thing here, where there is an x, if the string is plus x or only x, we need to actually convert that to a 1. Okay, that's a very subtle thing. That's probably why it's got a lot of downvotes. There's some subtleties here. There might be some other subtleties too that we're not thinking about. But yeah, you actually leave out the 1 when you're dealing with, when you have a 1 for the x. It's a slight, that's a slight, very slight edge case. I forgot about that. Yeah. So we also want, how much time we have here? I'm trying to go a little bit quicker today, I guess. I don't know. It's kind of too hard to go really quick. You kind of got to just take go at like a reasonable pace. Rushing these things isn't really that effective. So then we want also, yeah, we have our integers. What am I missing here? How do we actually split this up? Like, how do we do that? I guess what you do is you just have a string builder, and you have a vector of strings you return. Like not a string builder, but just a you could use a string stream, I guess. A string is fine. And you just add characters until you see a plus or a minus to the string, and then yeah, and then you see, yeah. So I guess there'll be an inner loop. There's like an greater outer loop that kind of goes character by character, and then there's a sort of inner loop that's not really an inner loop, but it just, once you see a plus or a minus, then you start a new string with that plus or minus there. I think that's it. Just do it that way. Yeah. So okay. So we'll have a parse routine. Let's write that now, and that'll break. And then the parse, where once we have our components parsed, we can or our string parsed into pieces. Then we can process those pieces to get the total the tuple of the coefficients of x and coefficients for I guess it would be the integer sum that doesn't have coefficients. Yeah, the sum of the coefficients for x and the sum of values that don't have that aren't paired up with any value of x. And then, like I said, there's some logic at the end to figure out if it's infinite solutions or if it's one solution or no solutions. Yeah, so overall I think it's not too bad. And we don't even need to write a parsing routine to split this into on the equal sign. I think we can just do that sort of in one. We can just find the index of the equal sign and then substring the equation. All right, so let's do that. So we're going to say for const character C and S. I'm going to loop over each character. We're going to have a string current, empty string. We're going to say if C is equal to either the plus sign or C is equal to the negative sign. And then we're going to update current. We're going to say we're going to return a vector of strings. So we're going to ret.pushback current, what we have so far, and we're going to say current equals, now this is interesting, you can do standard string of, you can do 1, and the character is going to be C. So that's kind of neat. You can do that. So I'll create a string of just that character, whatever that is. Or actually, you know what you want to do. You know what you're going to want to do. Believe it or not, a better way to do this is int I equals 0, I is less than or equal to. It's going to look a little bit confusing here. We're going to say s dot size plus I, and we'll say so I is greater than or equal to s dot size, or we'll say s of I. Right, so these are the three cases. So you also want to, when you go off the edge of the string, you also want to perform this operation here. And we would say just if I is less than s dot size. Oops. And I like to have braces everywhere. I think it's better practice to just have braces all over the place, even when you don't need them. Yeah, this is a tricky thing, but the reason you want to do this is you don't set current to anything. You actually break when you're greater than the size. This is actually all you need, I think. I think it's that simple. Okay. Actually could do, I think otherwise, oops. Otherwise, we update with s of I. All right, a little confusing. So what's going to happen is you're going to loop across the string, left to right, and you're going to have a current string that each character, you're going to update that current string with the next character in the, with each character as you visit them. If you see a plus or a minus, then you're going to update. You're going to push back whatever current is or was into our array of strings, and then you're going to start a new string with that plus or minus. If we happen to be at the end of the string, you're going to push back that string into our return vector, but you're not going to update this current string with anything. Excuse me, any other character other than the plus or minus or the end of the string, you're going to update current, increment current to that. You're gonna add that character rather to current. You actually could. You actually could do something like this. Actually, this is better. You're gonna update this to nothing, and then over here, we do it here. Whoops. Can you do it this way where you? So I was thinking do current equals, really it would be if I is less than s.size, then current plus equals. I think this works too. I think it's a little bit better. Well, you know, not really, because this has two branches, and this one up top would only have one branch if you put the else. Well, no, it has an extra branch in here. Yeah, I guess you can't really avoid the two branches. Well, this doesn't occur as often though. This particular check on whether or not you need to do a the secondary branch. I actually think the first way I had it is faster, because this is going to branch on every iteration, whereas what I had before would. This is only going to branch sometimes, whereas this is going to. Yeah, this is like one branch every iteration, and then this only occurs a fraction of the time where you have the second branch, whereas if it did the other way, you'd have two branches at every iteration. So it's slightly faster to do it this way, I think. Yeah, it's like a kind of a micro optimization, but not that meaningful, but it's just something to consider. You're a good problem solver. Hey, how's it going, Ganesh? Welcome. Hope your day's going well. Welcome. Thanks. Thank you. Appreciate that. I try. I'll take that compliment. I try. All right. So now we have our parsing routine. Hopefully that works well. We'll give that a shot momentarily. What I want to show also is the index of. So I want to say. So we'll say left. So we'll say standard string left is going to be equation dot substring on, we're going to say int equal sign, or actually we're using snake case rather than camel case. It's kind of a mix of snake case and camel case, right? Because this is camel case, but actually a lot of the STL is written with snake case. That's why I kind of prefer snake case in C++. Snake case and camel case, the only difference is camel case you don't have underscores, and you do the first character is lowercase, second character is uppercase. Snake case you do everything's lowercase, and you just put underscores between everything. Right, and here I am. I keep saying I'm going to try to do things quickly, but here I am. I'm going to do things quickly, but I am It's actually like index of, something like that. I have to look at the string library again. Here I'm saying I'm going to do it quickly, but I'm spending time explaining things. So string equals, or not equals, index. Let's try that. There's something specific I'm looking for. Equals, or not equal, index. No? Find. Or actually, no, it's wrong. Find. So there's find, and then there's also index. Is that there? Let's see. Also, are you guys hearing that? You are. Yeah, you get to hear my index complain. Windows complain. So I think it's just find. That does give you the position, doesn't it? Interesting. First substring equal to given character sequence. You can do this with a character, I think, right? Yes. Yeah, this is what we're going to use. But what's interesting is this does give you an integer. Yeah. Size type they use. They're supposed to use size type or size t for this. String size type. And the reason is that strings could be arbitrarily long. So you're actually not supposed to use an integer. Not supposed to use integer. I think it's size t you can do. I think that works. Yeah, that's what we want. And so now we can substring from. Now I don't remember substring as well. These are things that like eventually end up memorizing them. So it's position and count. Yeah. See, it's a little confusing. It's not a. It doesn't give you like an inclusive exclusive range of characters. It gives you like the beginning of the string and then how many characters. So you got to be very careful how you do this if you want to do this properly. Or doing this. So let's do. Yeah. Okay. We'll use this though. This is a little bit better than. Oops. It's a little bit better than. Hello. So you're from which country? I'm from the United States of America, USA. How's it going, Melito? Welcome back. Hello, hello. Welcome, welcome. Howdy. Howdy, howdy. The USA, the USA. All right, so the size is going to be, so if we find the equal sign in position, really, equal sign position, we want to say from 0 and then, I guess it would be, we don't want to include the equal sign. So it's because this equal sign position should be from, hold on, am I doing this right? Let me think about this here. So we want to start from equal sign position plus 1, and then we want to go to the end of the string. So I think if you don't include the rest of it, just goes to the end of the string. So if we have if we have 3 characters, A equals B, and the equal sign is at position 1, this will return 1. The size of our string is 1, right, up to equals. I guess what I want to say is that the position is 1. The size is actually going to be, it's equal, right? Because the position is 0 indexed. The string including that position would actually be the same value as that index. No. That's so confusing. There's a bunch of pluses and minuses going on here, where the size of the string is 1 more character than is 1 larger than the index of the last character in the string. That's always true, right? Take the index of the last character in the string, the size is going to be 1 plus that index. So we are finding that character, and we actually want to subtract 1 from that, but also substring is exclusive. So it's so confusing. I think we got it. I think is the way to do it. I think it works with if you just use example of like A equals B. The index we're going to give is 1, and that's also the size, which is just the first character 1. So I think it's just equal sign position we put here. Yeah, it's very confusing, but That's what we're looking for. So, okay, so, all right, we're gonna get strings. We're gonna just say parse left equals parse on the left side. Parse right is gonna be a similar thing. And then what we wanna do is, now we want to convert our, we have a conversion routine we're going to do. So auto convert, and I think we're going to just write this as, it's going to be an element by element thing. So we'll take a string, and we'll call that element, or elem, and we're going to go ahead and say, so size t, and I think we get n positions. There's, let me just see here. There's standard string n position, right? That's if we didn't find it, right? So size t, or index of x, we'll say, equals lm dot find x, and we're gonna say if index of x, so if x is not present in this element, then, see if there's anything in the chat. Okay. X is not present in this element, then we treat, then I treat. X is not present in this element, then I treat the element as an integer, a single integer. So if this is equal to standard string then position, then return standard s to I, string to I of element. Otherwise, now we found index of x. X must be x by the given format. It's guaranteed be the last character. If x is the only character, then we return 1. So if, what can we just do, element dot size equals 1, return 1. Otherwise, return characters to the left. Let's just say to an integer. Oh, I have my emails up. Oh, I gotta be careful. Give me 1 second. I'm gonna close my mailbox. Close my program. Because it's happened before where an email or something pops up, like I accidentally switch screens or what have you, and dox myself. So I think we substring here. So this is, I think that's fine. We're gonna substring on 0 to, it's actually gonna be the element dot size minus 1. Excuse me. Yeah, a little confusing. This could be wrong too. I think I have to test some of this. The conversion I have to test. Actually, what I need to test is this part. If I got this right, I don't know if I got this right. Let me actually let me do this. Yeah, and just print these left and right. I actually should put these on different lines. Okay, let's just do that, see what happens. See if it compiles. Favorite soccer club. Favorite soccer club. I actually don't play soccer. I played American football for a while. But I didn't, oh, these need to have, yeah. Yeah, I played American football for a while, but I actually wasn't really a fan of watching it too much either. I'm from New York, the United States, so there was a... Okay. Oh, interesting. It did parse the left and the right, and then... Okay, neat. It worked. Okay. Parse left, parse right, and it compiles. That's good. So we want to convert each of the elements. Now what's tricky about this is actually we do want to split. We actually want to split the string. So we could do convert elements. We'll do convert, and then we'll have convert elements, I guess. So the thing that's tricky is that this index of x, I kind of want to only perform this once. So I think what I want is I actually think I want to convert over the vector. I think I want to do it this way. This is you kind of have liberty to do this however you want, I suppose. Elements. Let's say for standard const standard string element in elements. Yeah, and I'll explain why I want to do it this way. Oops. It's a little bit more efficient to do it this way, I think. Yes, we'll say int x coefficients. Oops, coefficients. X coefficients, and then other coefficients. And I'm not spelling that correctly. And both of these, we want these to start off at 0. Okay. Coefficients, is that spelled right? No, I didn't spell that right. Okay. C-O-E-F-F-I-C-I-E-N-T. C-O-E-F-F-I-C-I-N-T. Yeah, coefficients. Okay. So the reason why I want to do this in one shot is because I want to, this index of routine, I don't want to run this multiple times. I want to run this once on each element, and then here in this for loop we can discern either if we put, so we're actually not returning these anymore. Now we're going to return a tuple, which is going to be built this way. We're actually going to take it here as a standard tuple of ints. That's what we're going to return. Let me put that wherever we want. And then we're going to return x coefficients and other coefficients. All right, how are we doing on time? 30 minutes. Oh no. Oh no. Taking so much time. Coefficients. Yeah, I mean, I kind of expected that, right? Like when you get that many downvotes, that's usually wise. People don't like spending all that much time thinking about the problems. So here we're actually going to just increment x coefficients, and no, excuse me, this is other coefficients. The variable is quite a challenge to type. I probably shouldn't have used so many characters for these variables, really, if I want to do it quickly. I want it to be readable though. Alright, so if we don't find the x, then we just outright other coefficients. But if we do find x, then we say x coefficients plus equals 1 plus plus. And then otherwise return, so we'll say size t, or no, just int val, we'll just say val, yeah, we'll do it that way. Well, again, for readability, we'll do it that way. I guess I could put this on one line, I don't know, I guess it's fine. Yeah, I guess it's okay, that's fine. Okay, let's try it this way. I think this is what we want. Now the question is, so we can convert parse left, parse right into, now we can say left tuple, right tuple. You could even do left x, left other. you can automatically destructure is going to be equal to convert on parse left, and same. Actually, we'll do right other and right x. Okay. Now we have logic for, I think we mentioned before, the logic we want to do is, so we'll say x into x, other is going to be, oops, x is just going to be left x minus right x, right? We're going to combine these two, subtract the right side from the left, right? Move everything to the left side, and left other, oops, other is going to be left other minus right other. Keep it simple, and then we say our logic is if, so if x is 0, then we have two questions. If x is 0, then if other is 0 as well, we have return infinite solutions. So we're saying that before, solutions. And then otherwise, no solutions. Yeah, no solution. Okay. Otherwise, we're going to return a string x equals, whoops, and this is going to be, I think it's other divided by, no, is it integer division that we need to do? So that's another question. So that's a really good question. There's exactly one solution for the equation. Ensure that the value of x is integer. Okay, great. So we can do integer division here, and we can do I to s, something like that. Or I think there's two string we can use. I think that'll work. Whoops. And that should be it. Other divided by x, right? So the coefficient, yeah. So what's going to happen is we move everything to the left side. It's actually negation, I think, this other. So we're going to move everything to the left side and say x is not 0. Then we're going to take our other coefficient, subtract it to the right side, and then divide by the coefficient for x. And that's the negation. So negate and divide, and then it should be an integer. And we just, yeah, I think that's all we need. I think that's it. Interesting routine, set of routines here. Is it me you're addressing? I'm asking William, sir. Sir, I'm Manchester City fan. Yeah. Manchester, that is, I don't know where Manchester is. Is that London? Or not London, excuse me. In Great Britain. I guess it would be Great Britain. All right. Kind of expecting, did I misspell this? Coefficients, not the same thing as coefficients. We don't want coefficients, we want coefficients. Coefficients. I thought I would spell that wrong. Let's see if it compiles. Oh, did I? That's okay. Spelling is good. Infinite solutions. And I've been doing a bit of scripting lately, and we don't need those characters. Okay, terminate call if throwing instance invalid argument s to I. Ooh, interesting. Really? Okay. So that must be our conversion that's happening here. Where is that happening? Is that probably the bottom one, I think. Let's try check 1 and check 2. So let's see which one it is that's causing this error and why. Check 1, 1, 2. Yeah, I thought it might be 2. So this might be too big. think about that for a second. So if we have x, we say if the size is 1, let's just say the size is 2, we want to take 0 but not include the x. The x could be, I think this is just wrong, maybe the substring. Maybe that's why. No, invalid argument. Let's actually print, let's see what's causing the error. We can actually just print this all together. Trying to wrap your brain around like how to exclude that one character at the end. It can be tricky. Plus. Oh. That's interesting. Oh. What did we do? Oh, plus x must be what it is. Oh, I see. Okay. That's interesting. I messed that up. Could be just x. You could do else ifs though. You know, you could do it. This isn't the worst thing. I think. Okay, I think I understand. So there's a few edge cases here. I think, yeah. Okay. I kind of thought maybe I would miss something. So plus x. If it's minus x is another one that will be kind of tricky. I'm glad for these test cases too, because yeah, I'm glad I got caught on the test case rather than failing it directly. Okay, there we go. So the rest of our code looks reasonable. All right, I'm gonna get rid of these. Is there any other debug statements we have? I think we're done. I think we got it. Yeah, 40 minutes on this. This is a challenging question. I don't know if it's correct either. We have to try some other test cases. This definitely would be a challenging question. Especially in an interview, this would be extremely challenging to do quickly and efficiently. Okay, we got it. There's probably an edge case that I missed. I kind of want to try some other test cases, but I also kind of just want to submit it and move on. Shoot, I thought maybe that'd be the case. Maybe something. Some edge case somewhere, almost certainly. Why is this wrong though? Oh, I think I know yeah, okay, I thought about, I forgot about that. I thought about it, but I forgot to work on it. Shoot. No. Yeah, the reason for this problem is that, yeah, it should be skip empty strings. Yeah, I'm pretty sure that's the edge case that we missed there. Yeah, okay. There's probably some other edge cases too. Again, I'm like kind of just want to get through this. Oh, there we go. Got it. Okay. Yeah, I forgot about that. That's all right. So part of the reason why I want to, we should probably just go to the next problem, but sir, you will cover Java problems. Comments are really nice. I actually had stopped covering Java problems for some time. I mean, we can go over Java. We can do a couple Java ones. That's fine. What I'm going to do is actually I'm going to end the stream and start a new stream. So that way each stream is broken up into like just those problems. But yeah, so something to mention though, like this is very specific to this format and problem. This parsing routine is not a routine that you would want to have sort of free as a free function. Same thing here, this convert is like not something you want to have as a free function. And like this edge case is related to this parsing routine. So this is actually like this is kind of how Python parses strings, in that there will be an empty string pushed if you had, as you saw, if you had like a plus x or a minus x in the front, which I completely forgot about. I actually had considered that before, but I just forgot about it when I got kind of got into the other parts of the code. But yeah, that was pretty bad on my part. I actually should not have gotten that wrong. Yeah, like I said, there's just a certain bunch of different edge cases that I just like kind of forgot about. This one I forgot about, and also this one. I thought, actually, like I said, I thought about this ahead of time, but I just forgot to put it in here. And then also, yeah, these cases too are tricky. Tricky. All right, so let's go ahead and stop the stream and then start it again on another problem. But thank you guys for watching. I appreciate it. Yeah, if you want, I could do another Java. I could do a Java problem. That's perfectly fine. Let's do it. Thank you again for watching. I'm gonna get another problem going.